Okay, so I'm going to talk to you guys about DHCPv6, and what I'd like to do is I want to go through some basics. I'm going to try to draw some analogies. I mean, there's few enough people in this room. Anybody here familiar, active user of DHCPv6? Anyone? Okay, good. So what I'd like to do is give you guys some background on the on the protocol. I'll talk about some analogies where v4 and v6 are they're similar to one another, but also point out some of the substantial differences between the two protocols. Okay, I'll tell you a story real quick. We did a panel at Cable Labs, which is where we do a lot of our standards work in the cable industry. And a guy walks up to us walks up to me after the panel and says, wow, I didn't know DHCPv6 wasn't just an upgrade to v4, right? So I mean, so that was like really a far left example, But my point to prove is, there's still some. 2 years ago, there were still some misconceptions about v6, DHCPv6, and how it relates to DHCPv4, right? So I make no assumptions. I'm going to go and assume that we're not going to have that problem here, but give you an example of some of the comments we've gotten over the years about DHCPv6. So this is kind of the eye chart version of the various topics that I'd like to kind of get into in our tutorial here. And since we have a small group, the one thing that I think is going to be best for us is, if you guys have questions along the way, you want to kind of get into something, let's do it. Let's just, let's make this as useful as possible for everybody, right? Let's not make this like, a 90-minute nap. So, so one of the things I kind of assume here is that, that we have a common understanding of at least basic understanding of how DHCPv4 works, right? Discover, offer, request stack, the renewal process, clients, servers, relays, the basics. I'm going to give you guys some pointers here to some interesting RFCs that are often referred to throughout my daily life, kind of doing IPv6 and DHCPv6 for a cable company and DOCSIS deployment. 3315 is the core spec for DHCPv6. 3633 is where we get into the prefix delegation options. So when we delegate prefixes using DHCP to clients that are able to do that, a popular model for that is home gateways, right? So you can think ahead a few months, years, when you have a new home router that can support IPv6, and you can be delegated a prefix. That in a cable network, that's likely what you'll be using. 3736, we don't use that a lot in DOCSIS, but has its place. Not necessarily in a DOCSIS network, usually an enterprise type of vibe for stateless DHCPv6. The DHC working group page, I co-chair that with Ralph Drums, so happy to help out and answer any questions you have about our working group and the protocol in general. So DHCPv6, the model we have today with DHCPv4 is largely basically very singular, right? I'm asking for an address or configuration information almost all the time, right? Discover, offer, request stack. I basically am getting my address and configuration information. With v6, we actually have the ability to do a bit more than what we're accustomed to with kind of the v4 equivalent. We can ask for one or more addresses. We can ask for one or more prefixes. We can ask for none of those and just ask for configuration information. Or we can ask for all the above, right? So there's a bit more flexibility here. But there's often opportunity for confusion in that people try to tie all these concepts together, and it takes a bit getting used to, at least from what I've observed. The stateful mode for DHCPv6 is really analogous to what we know and love today in v4 world, right? Where we basically we have a 4-message exchange, we get address information, configuration information, and stateless DHCPv6 is where we basically have an address from some other mechanism, whether it's statically assigned or configured, and we're only using DHCPv6 to acquire the configuration information. Okay. Obviously, DHCPv6 requires an IPv6 transport. Not going to work over IPv4. And like the point I called out earlier, kind of for at least mild entertainment value, is V6 is just simply not an upgrade to V4. It is a substantially different protocol. I mean, there's some similarities, but it is very different. The fundamentals of DHCPv6, our clients listen on V546, servers listen on and relays listen on 547. Again, not 67 and 68 like we have today in V4 land. Heavy use of link local multicast for the intercommunications between processes, right? Whereas in V4 land we have a lot of broadcasts, kind of layer 2, 3-ish type of vibe. That was substantially cleaned up in 3315 with DHCPv6. And the act of relaying packets is actually a bit cleaner with DHCPv6. Where today, when you relay a V4 packet for DHCP, you actually lose some information about the relays that are intermediate between the client and the server. With V6, you actually encapsulate information about each of the relays that the packet has gone through. And we also have and one of the most substantial differences outside of the transport is we actually have a different encoding mechanism for DHCPv6 than we do for V4. We have, it's a lot cleaner from a protocol point of view, 16-bit option types, it's been substantially improved upon. So we've made, I think we took the opportunity with V6 to really adjust and enhance where some of the V4 things fell short. Just kind of a quick comparison for those who are familiar with V4. For DHCP4, we have discover, offer, request, act. In V6 land, we have solicit, advertise, request, reply. I'm kind of abbreviating some of these things here. We have release, which is similar. We're starting to get into some things that are somewhat unique with information request. So this is where you would simply request configuration information from a DHCP server, and you have an address elsewhere. Reconfigure. You kind of have an equivalent in V4 land, but my experience tells me that this is not widely used. There's a security issue, of course, for new. And I'll give you a real live use case. In a real network where reconfigure is actually used today, and specifically in DOCSIS environment. And of course, you have relay 4 and relay 5 messages. And again, that kind of goes hand in hand with the notion of relay chaining that I had kind of mentioned a minute ago. So take a half a step back. I don't want to get too far into the protocol of DHCPv6 without talking a little bit about some things that have generally been hot topics on occasion with regards to IPv6. So some of the original versions, I think it was RFC 2461 and 62, we specify the M and the O bits in our router advertisements. So I'm going to kind of stick to what is commonly conversed about these bits. So generally speaking, when we talk about DHCPv6 and the role of routers and how DHCPv6 is supposed to be initiated, we quickly get to the router advertisement and the M and the O bit, right? In theory, you get an M bit, and the node, if it supports DHCPv6, is supposed to initiate a stateful DHCPv6 transaction. If you get the O bit, in theory, you're supposed to initiate a stateless DHCPv6 transaction. Now, beyond that, you should be able to potentially do one or the other or both simultaneously. So you can see that the opportunity for confusion, and like I said, this is hotly debated. Thus far, my experience kind of shows me that there are some nodes out there that will actually follow this behavior as long as they have a client. So, like Sun has a client, Vista has a client, my Mac doesn't have a client, my Linux box doesn't have, popular kind of bundles of Linux don't really come with what I would call a current version of DHCP client, right? So there's still a mixed bag, right? And some of them still require that you start your client manually, right? You have to kind of explicitly say, I want to go ahead and do DHCPv6, so I'm going to go ahead and type in the command and go, right? So it'll be interesting how this unfolds, because in the later versions of the V6 RFCs, we talk about, the M-bit's still kind of there, but the behavior is loosely or almost completely unspecified, right? So we're kind of hanging out there dangling from that point of view. But I can tell you, for example, from a DOCSIS point of view, cable modems, generally speaking, they expect to see the M-bit, and then they'll do DHCPv6, stable DHCPv6, right? So I'll draw analogies throughout our time here together, where I'll tell you what we've done in cable, kind of keep it general, but my desire is to give you some background on DHCPv6, but also some real world applicability to how we've implemented DHCPv6 and how we've kind of laid the requirements for the same. So in DHCPv6, we have this concept of a DOID, the whole kind of attribute of CHAtter, which we all know and love as kind of what is uniquely identified as the DHCP client. That changes dramatically, right? It's no longer a 48-bit MAC address in CHAtter or a client ID field in DHCPv6. It's actually depending on which one. So there's 3 formats of DOID. It could be a fixed length. It could be variable length. And there are guidelines in the RFC where one might use one type of DOID over another. The key important point for everybody to note there is if you have a significant reliance on the presence of a MAC address in any of your systems that you do today for, I don't know, NAC, like a network access control, for example, and you want to go to V6, you have to factor that in, right? You have to make sure that you're aware of the fact that that field's going to change. It may be a different length. It's not going to be 48 bits anymore, that's for sure, right? And it's also vendor specific at this point. There's a vendor code which you'll see in some of the DOCSIS examples, where you actually will have a vendor assigned identifier, and your DOID will kind of be coupled with that. And I have some packet traces that I'll be able to kind of show you that. But my main point here is MAC address. You need to kind of think outside the box now, because that's going to be changing. So stateful DHCPv6, in short, it's our four message exchange, similar to what we know in 11v4 today. We have solicit, advertise, request, reply. There is a very interesting conversation piece here about stateful assignments from DHCPv6, the rapid commit option. So rapid commit, I believe, has its place in the world of DHCPv6. Rapid commit is largely a two-message exchange. And it's basically, I'm a client, I ask for an address, and I advertise the ability to do rapid commit, and I will immediately be offered an address. Right? I will not go through the second step to kind of validate the availability of the address. Right? There are some challenges to using this, but there are also some upsides. Right? It's 2 less messages. Right? Happens faster. But in my network, for example, using rapid commit would actually have some challenges, because we would have potentially multiple servers believing that they're authoritative for the same client. Okay, so every environment is going to have a different circumstances where they may or may not be able to do or leverage rapid commit. It's often widely supported, to be honest with you, because it's pretty low hanging fruit from an implementation point of view. I've noticed that a lot of the clients almost always start off supporting rapid commit first. And another interesting point is when we configure DHCP servers today in v4 land, and I'm guilty all the time of doing this. I'll configure like a whole truckload of options and have them, sent back to clients irrespective of whether they ask for them or not in the parameter request list. In v6, there has been a more strict adherence to what I send back to a client compared to what it asked for. If it didn't ask me for it, I'm not sending it, right? So we start to break the model of assuming that I'm going to send you back everything whether you ask for it or not. That we're seeing that model change a bit as far as implementers are concerned. So kind of a nice pretty diagram of what a non-relayed stateful DHCPv6 message exchange looks like. And we have text version of a Wireshark trace. So I'll point out a couple of things here, because this is kind of the first place where we're going to see some of the things that we've talked about in the slides here, right? So we have our client identifier here, and you'll see that this client in particular, and just a shout out to ISC, this is all their software. Thank you, Susanna. It was something I was very familiar with, so. So we have link layer plus time, right? So time is used to add some variability to the use of it, but you also notice that this one, the link layer, it actually leverages, essentially the MAC address. We have an option request option, which is ORO. So this is what I was telling you about a moment ago, where if it's not in here, generally speaking, DHCP server is not going to send it back, right? And then we have the elapsed time, how long essentially this transaction's been kind of live on the network here. IANA, which is essentially where we get information about our addresses or the address that we're being assigned statefully. We have an IAID, and I'll get into some of these things here, but I hesitate to kind of get too deep into these things because I don't want to put you to sleep with some of the particulars here. But you'll see that we have our timers, T1, T2, and of course information about our IP address and constructs that are related to IPv6, preferred about lifetimes. Okay, so in a v4 world, you'll generally see only these timers here, and they indicate renewal and rebind or expiration. Right now, you have this notion of kind of an expanded notion of lifetime or timers, where you talk about an actual lifetime for the address itself. So what you'll notice here is valid is generally the greatest value. It is the absolute maximum length of time that this node should use this IPv6 address. Has nothing to do with IPv6 in technical speak. This is the preferred lifetime. So once this node reaches a point where I've gotten to preferred lifetime, I need to basically, as a node, start to think about, if I'm not instructed that I can continue this address, I need to start thinking about stopping the use of this address, right? So that's kind of bad grammar, but I think you follow me. And these are what we call, our timers for DHCP. I'll renew at this number of seconds, and I will essentially expire it if it doesn't happen at that time. I'll get into some in-depth information about how you would see this in a cable deployment and how we adjust these values relative to a DHCPv6 redundancy model, which today is protocol free, right? And not on purpose, it's just not there yet, right? We don't have a failover for DHCPv6 yet. So we had to do some things to make it so that we could deploy DHCPv6 to support our IPv6 deployment, and essentially had made adjustments to the model that we use for deployment, so that we reduced the opportunity for undesirable events on the network. What else we got here? All right, so the next three slides are essentially the remaining three exchanges, right? So you'll notice that this one's the advertised. I will not go through all these. Actually, I should go back for one second. In the solicit, which is basically the equivalent of a discover, or kind of the Morrow equivalent of a discover, you'll notice that there's an address in here already. So he had one, and as a hint, he sent it back as a hint to the server to say, by the way, if you can give me this address back, I'd like to have this one, please. Right. So in some cases, you'll see : there. But it all depends on what the prior state of the client was. So the advertised, a lot of the same fields here: transaction ID, IA, NA. This is the address we're being offered back. Server identifier, which is different compared to the solicit. This is new, something that we didn't see in the solicit. Everything else is pretty much we talked about on the solicit. Request, the equivalent to the v4 request. We know we're going back to the server in the format exchange saying, yeah, I really would like the address you just offered me. And then, of course, the reply. The final message, kind of the equivalent of ACK in the v4 world, right? So if you guys don't mind, maybe show hands for objection. I won't bore you by going through every one of these here slides. I added them largely because people download them and want for reference afterwards. They'll be in there, right? But I really didn't have any intention of going through, I mean, unless you guys want me to, go through like 60 slides worth where we're looking at like ASCII text. So, yeah. So rapid commit. We talked about rapid commit, two-message exchange. Talked a little bit about some of the shortcomings, but also some of the positive aspects of rapid commit. Just something to think about. I won't belabor it, but like I said, I would have some problems leveraging rapid commit in my network because of the quantity of servers that we're using on the network, right? So at bare minimum, we have 2 DHCP servers for redundancy, and in our deployment, we would basically have both of those servers believing that they are authoritative for that address. So to kind of put a little bit of additional context on it, if you have OSS systems or other internal systems that basically talk to DHCP servers to get information about who's been allocated what, this could actually create some problems as far as keeping data straight. If you leverage lease query, right? Lease query is something we'll talk about here shortly, and you want to talk to the DHCP server and say, give me information about this binding that this DHCP server has allocated, and he gets conflicting information back. You might be hosed, right? So something to think about.
But you said many of the clients today are kind of geared towards rapid.
You can turn it off. So what I found, in the past 5 years at least, most implementers will first implement rapid commit, but then they'll go and do the full stateful exchange, right? I can't think of one that only does rapid commit off the top of my head, right? Like, and we'll talk about a few. I mean, again, ISC, this is IC, all the examples are IC based, but Dibbler is another one. I can tell you that cable modems, the DHCP client cable modems, in the beginning they supported rapid commit because it's the process, right? People are kind of getting their feet wet, they're rolling their sleeves up, learning how to kind of write code for DHCPv6. They want to kind of find the thing that they can hit first to kind of get their brain around what's going on here, and then they go from there, right? There's been a lot of that over the past few years. Just the way we develop software products, right? New protocols.
One thing, I apologize. Unfortunately, I have to actually go here in a couple minutes to do some business. But the thing here is, one thing I'm trying to understand in this protocol is, in DHCPv4, you had issues with voice over IP implementations and such due to DHCP starvation. Various types of denial of service attacks ran through DHCP. If you could just maybe a couple of sentences as to how that may be avoided in DHCP6.
Well, so assuming you're talking about, I've configured a 24 on my DHCP server, -1 for the router and the -1 for the broadcast, and I just kind of have a client and I blast it and I suck up all the 253 addresses, that thing. Well, I mean, first and foremost, right? I mean, if I just put kind of the most obvious, a simple example, I put a 64 on a DHCP server, right? Which is it's common. I'm going to be there a while trying to DOS that guy, right? I'm not all seriousness. I mean, it's going to take a while. Now there are some other implications, right, that we should discuss about that, right? So now, even if I never exhaust all the addresses, there's still going to be an impact, right? If I cause this DHCP server to now suddenly allocate 1 billion stateful bindings, there's going to be some other issues other than that. I mean, it may never exhaust, but the server may crash because I just it used up all the memory on the box, right, or what have you, right? So there are other challenges associated with that. I think full exhaustion, probably not one of them, right?
Yeah, I would agree.
Right.
Right.
Right. Now, something else worth noting. So I hope you guys don't mind kind of take a little left turn here, right? But something to consider, right? So your DHCP server, you want to run it on the same box and the same process, right? So ISCs is not like that, right? But there are others that I use, third-party software, where the same binary process supports IPv4 and IPv6. Now, I could separate them, run potentially two separate processes on the same box, or I could split them apart, right? the reason I bring this up is because you have a deployment, because it's a separate protocol now, right? So now you could do that. You really could go and put like we use Cisco CNR in our network. So that process is one binary, supports DHCPv4 and DHCPv6. So I can put it all in one box, all in one process, right? But you have to appreciate the deployment challenges associated with that, right? If something goes wrong in the V6 process, it's going to affect your V4 processing as well, right? Right. So I blow the server up in V6 land, right? V4 is going to have a problem too, right? Now, if you have a separate process, it might be more difficult to manage, but I'm a little bit more insulated, right? So I'm not telling you the right way to do it for you. I'm just telling you, think about it, right? If you're going to use DHCPv6, these are some things you need to consider, right?
I'm sorry, I didn't mean to derail you.
Dude, that's a great question. I mean, it's by all means, keep them coming. I mean, I think that's what this is for, right? I mean, my hope is to offer you something valuable, that's useful. So, rapid commit. I forgot where we left off with that, but not a whole lot more to say about rapid commit. So.
You have a question, I guess, more practical implementation question. So the thinking behind rapid commit was that you're going to conserve some resources, whether it's time or I'm guessing that's why it was implemented in the first place, why it was devised in the first place.
Well, I mean,
It's the amount of time that it takes to get a host to have addresses or addresses.
I think that's one aspect of it. I think the other aspect of it goes back to the gentleman's question in the back, where part of the reason why you go through the 4 message exchanges, there's that last pair of messages. You use it to make sure that nobody's had this, or to give other DHCP servers opportunity to reply or what have you. This one here, I want to rapid commit. I want to give the address because I don't care. I've got address to burn, right?
Right. Right. So then, I guess my follow-up question to that is, it sounds like, are there any circumstances where you have redundant DHCPv6 servers and use rapid commit, or are they mutually exclusive?
No, I mean, I actually would think, so outside of cable head off, right? DOCSIS deployment head off, kind of enterprise style deployment, I might actually consider that, right? It all depends on interactions with northbound systems into your DHCP server. A DHCP server nowadays seldomly sits there by itself just doing DHCP, right? Somebody's talking to it over SNMP or lease query or digging through log files and kind of recording information so that, you can do like network access control, right? It's popular now with DHCP, right? So, I mean, I can absolutely see the opportunity for rapid commit to be coupled with pairing of DHCP servers so that you can offer a different aspect of redundancy with DHCPv6, right? Because honestly, if you're looking for speed for address allocation, you could auto configure the addresses. You could just tell, you could have it do auto configuration and just do, use DHCP for configuration information like stateless transactions. Certainly an option. Yep. So the only thing I'll point out here, is our there it is. Rapid commit option. Tells the DHCP server, so there is something interesting to note here. Client says I can do rapid commit. If a DHCP server sends back a reply, the DHCP server, said, great, I'm going to go with the flow and I want to follow your hint to do rapid commit. If I sent an advertise back, stateful DHCP keeps going, and essentially the rapid commit bit was, not acknowledged or not adhered to. So the DHCP server in this case is basically authoritative. He basically said, yeah, you know what, I'm not going to do rapid commit, even though you said you can, so we're going to go off and do stateful DHCP. Reply, kind of skip through that. So relayed DHCP packets, messages, kind of similar. Again, looks and smells a lot like DHCPv4, right? Except for the actual packet traces, which you'll actually obviously note that there's a difference. We have relay forward, relay apply messages, right? So link local multicast is the relay agent. Relay agent encapsulates the DHCP message, the DHCP packet, and does a relay forward. With the encapsulated DHCP message in the relay forward message, relay forward back to the relay agent, decodes it, back to the client, like local multicast, right? Back and forth, 4 ways, 4 messages, and we have a DHCP exchange. So I apologize if this is not user-friendly from a visual point of view, but I'll try to make it so that it's at least we can extract the value from the text here. So we have a relay forward message. You'll notice down here we have the relay message and the encapsulated DHCPv6 message. If this were to pass through multiple relays, we would see this packet encapsulated in a nested fashion for every relay passed through, right? So we have information about every relay it's gone through. Advertise. So this, I want to kind of cruise through these a little bit, unless anybody objects. And of course, solicit, advertise, request, reply. So stateless DHCPv6. Again, we assume that we have acquired an address through some other technique, whether it was statically, auto configuration, or whatever. And we're using DHCP just to get configuration information. I want my DNS server IP addresses. I want my NIS option, SNTP, or whatever. The interesting point about this that I'll make relative to V6 is right now, as far as widespread availability is concerned, I can V6 myself on this network, right? But if there's not a DHCPv6 server running, I don't have any way to get the DNS server IP addresses, right? So, we have a dual stack network here in NANOG. Even if I'm V6 enabled, all my DNS queries are going over IPv4, unless I have a way to get configuration information onto the box. VI, my etcresolve.com file, your network control panel, whatever, right? So, that's an important point to note. Now, as an aside, we have, various activities within the ITF where we're talking about putting more information in RAs, like DNS server information. It's relatively new. Probably, I think the first time it came up was maybe a year and a half or so ago. But you have to appreciate that there'll be some patching of clients out there in the networks that would potentially make the ability to use that in the near term in a uniform fashion somewhat complicated. So, stateless DTP, information request, reply from the server. And you'll notice, again, a very abbreviated exchange. I basically say, here I am, I'm a DHCP client, and I want this configuration information. DHCP server says, here you go, have a nice day. Is that what he said? Okay, so far, any questions, comments, anything you guys want to kind of get into other than what the direction we've taken so far?
Is there something coming up with default gateway addresses and multiple servers?
There are none.
There are no options.
Nope. No. Interesting that we can talk about that for a second. It is another hotly debated topic because generally speaking, people, that's what router advertisements are for, right? In a router advertisement, sniff on any one of your boxes here, your router advertising itself will basically tell a node, here's your default route. We often get into these kind of debates about whether or not we need a default gateway address for DHCPv6. I can tell you, as of now, there is none, right? And we haven't seen. We kind of occasionally get that topic that comes up at ITF in the working group to talk about the need for it, but at this point, there's no. I'm not aware of any active draft that specifies the default gateway.
When we considered using it, we were afraid that other customers would share the and start using RAs themselves and then pull the traffic to them instead of to our routers.
So I'd like to talk about that either on or off session here. In my world, if you're on a VLAN in two scenarios, right? Whether you're on a data center VLAN, it's my data center, right? And they're my routers, and they're my servers, and I'm sending the RAs that the nodes are seeing. They're all the same. They're all for me, right? Even on the cable network, right? CMTS is sending our router advertisement down the RF to the cable modem. My CMTS, one CMTS is going to see it, right? I don't have a scenario in my environment where I may have two CMTSs from different people, different companies, different organizations that are going to kind of present conflicting information to that node. I've always kind of been a little bit, easily confused by that scenario, right? I mean, so I don't want to kind of ask you to talk openly about something that we should talk about offline, but I'd like to talk more about that. But it's a really good point, right? That would be a problem, right? So, I guess purely from a technical point of view, that could be a challenge. I mean, you'd have to coordinate closely with whoever you're sharing that VLAN with, right?
Just one rack full of dedicated servers, and every server goes to a different customer. I don't want to give /28s or 59s or whatever, so one big VLAN every customer can contact updates to other customers. So they can all move RAs, full traffic.
But the common network isn't. So it sounds like a hosting model, right? Right. So from some of the conversations that I've had with people who run those kind of networks, it seems to me that the common network, the network is not associated with one of the two, with the clients, the people who are hosting things in that network. It's the guy or the company who's providing the infrastructure, and then I have clients. But after the day is done, they still have to share the common network, right? It seems to me, right? I mean, the scenario that we're describing is it's your network that you happen to be sharing with another guy, and you're trying to differentiate from a layer 2-ish point of view the traffic, right? So I guess I could use a little help there, right? So I like to catch up with you afterwards. So prefix delegation. So we're going to get a little bit into this. So this is basically where the best example I can offer you for prefix delegation is your service provider says, well, we're going to start off with new IPv6 connectivity, and if you have a home gateway that is V6 cable, it's a router, I want to delegate you a prefix of some length n, and they're going to do it through in a cable network, they're going to do it through DHCP, right? And these are the options that would be used to communicate that prefix down to that prefix delegation client, which is at this point now the home gateway. Similarly, for message exchange, solicit advertiser request reply. The main difference now is I have IAPD options in the packet, right, versus IANA, the non-temporary addresses. I now have IAPD, right, and they're not tightly coupled to one another. They're kind of orthogonal. I can send both, or one, or none, right? So let's see here. This is my solicit. Not so interesting, except for where is my, yeah, solicit's not so interesting. We'll show you the advertise, where we start advertising the prefix down. We have the IAPD option here. Again, so this is the new part of these messages. And again, we have a lot of similar attributes: timers, lifetimes, length, the prefix, and the length. Okay. And kind of sidebar for conversational sake here. This is where you really start to care about redundancy. Okay. When I'm allocating unicast addresses, I've got so many of them that the technique that we'll talk about later, it's really easy to provide, well, not really easy, but it's more straightforward to provide redundancy for individual address assignment redundancy. Where you come into prefix delegation, you start handing out for DHCP fairly sizable chunks of your address space, right? In not in the grand scheme of things, but kind of relatively speaking. You now have a greater need to maintain state between two DHCP servers, right? So I believe it'll be things like prefix delegation that's going to encourage work in the IETF for implementers to make available redundant, from a protocol point of view, DHCPv6 servers, right? Because right now there's none. There's no inter-server protocol, no protocol for inter-server communication to facilitate the exchange of state, right? Unlike the failover address for v4. So same idea, just different options here. I'm going to talk a little bit about IA, one other IA option that we haven't gotten into, IATA, right? So IANA is kind of like the options for non-temporary addresses, so addresses that would be expected to be a bit more persistent. IPDs for the prefixes. IATA are these notions of temporary addresses, right? Very similar to the construct on an IPv6 box itself, right? There's, you have these addresses that if you're unable to use them, they're kind of randomized to some extent, but randomized isn't really the best word. We have the ability to transmit those with DHCP as well. Okay, so any questions? So far, so good? Okay. So renewal rebinding, similar constructs. We talked a little bit about this when we kind of did kind of a rundown of how do we get from preferred lifetimes to valid lifetimes to preferred to T1s and T2s, right? We renew at T1, we rebind at T2, and the node itself at the valid lifetime should cease using the address. Now, something to note: your renewal is going to be multicast. It's going to be multicast on a local link, right? So your relay agents are going to now pick up your renewals consistently, right? Because in v4 land, they'll get unicast generally to the DHCP server, right? So if you expect to see information about your relay agents as part of that renewal process, in v4 land, you generally don't. You lose that, right? In v6, I don't want to say by default, but almost by default, this is the behavior that you'll observe. Okay, so we have renewal rebind messages. I have a question. Would it be of any value to you folks here if we made the actual Wireshark versions of these traces available, so that you could actually open them up and actually take a look at the packets themselves? If that's something that you think would be useful, just kind of maybe drop a note to me, because you'll have my address at the back of this, and I'll make them available. Because the one thing that I noticed that we're losing here, we're not really getting a good feel for the encoding the differences that exist between v4 and v6, right? If you were to look at this in a sniffer, it would jump out at you right away. So now that's something that's generally applicable through all these text traces. Rebind. I'm not going to bore you guys there. Okay, so server preference. Interesting option, and coincidentally, one of the attributes that could be used to provide redundant DHCPv6 servers. Okay, so server preference is essentially something you configure on the DHCP server, and you use it to suggest to clients that one server is more preferred to another. Okay, generally 0 to 255. The values, if you have a 255, then you're king of the hill, right? And if you have multiple ones that are 255, then basically it's up to the client to choose based on option sets that come back in the advertisements or speed of response. For example, if two DHCP servers that have 255 preference send back to a client an advertisement, same exact option set, but one gets there somehow a lot faster than another, well, they'll take that one, right? What we do here, just as an aside, so we start talking about different constructs, and we're building up all the pieces that ultimately we'll put together towards the end to show you how some ways that you could you can offer a redundant DHCP. This is what we do to basically encourage traffic to go to one server compared to another, right? Instead of kind of trying to equitably distribute between DHCP servers, maybe we want one to always be preferred over another, so that we know that it has more truth from a data point of view, right? Instead of having to kind of go and talk to multiple DHCP servers all the time, right? So one thing that that you'll see in the examples later on, we'll have the guy that we call the primary, right? To pull kind of nomenclature from the v4 land, we'll have the primary have the 255, and we'll have what we call the secondary server have something less than 255, maybe 128, probably not 0, but 128, so that we can actually differentiate between two DHCP servers. Because we do call one, at least in my experience, we call one primary and one secondary, right? Okay, so reconfigure. One of the problems that we've had with force renew and V4 land is, there seems to be a pretty decent opportunity for an exposure there to have clients renewal forced on a client, and it was kind of undesired, right? It was kind of uncontrolled. With reconfigure, what we have is the ability to fairly nicely control the triggering of a renewal or a rebind event from the DHCP server, right? You have to implement the reconfiguration key authentication protocol, and it is important to note that you do not have to implement DHCP authentication as specified in 3315. We've had a number of implementers freak out because they thought they had to go and do all of DHCP authentication for V6 because it is lengthy. It's a lot of work. This is really a subset of that, and in my opinion, worthwhile for whatever that's worth. My 2 cents. And I'll give you a perfect example why. So with V6 now you've got this vast address space. What are you going to do with it, right? Well, why not extend the leases that you offer to clients and have them hardly ever come back and renew to you? Without reconfigured, you'd have a problem, right? You'd have to manually reboot them or wait for half of infinity for it to renew. Well, you basically lose contact with the computer, right, or the client. Well, you can now extend those bindings, potentially reduce some overhead on your DHCP servers, probably on your network, not that much, but still something. And if you ever need to do anything to trigger a reconfiguration to the client, you leverage reconfigure, right? You send it a message, does renew. If you need to change its lifetimes or T bindings temporarily, there you go. You can do that. And after all said and done, you just put it back to the way it was, and off you go, right? I see that as an opportunity that we have with V6 that we really don't have before, right? Because of all the churn in the network, right? Particularly in larger environments, there's always address space changing on the network, right? Well, V6, if I put a 64 in a CMTS, well, that 64 I expect is going to stay there for a while, probably for the lifetime of the box. And over time, as DHCP continues to mature and evolve, we can kind of take advantage of some of the opportunities that we have, right? Extend those leases, use DHCP reconfigure, so that if we ever need to get back in touch, we can, right? And we can affect change on the client in a controlled, secure manner, right? I think there's an opportunity there. Any other question? All right. So we're going to start kind of getting into some of the tail end of the dry, boring kind of core protocol stuff, and getting into some of the DOCSIS pieces of things. So vendor information options. You'll notice that there are not nearly as many DHCP options for V6 as there are for IPv4. Not only because it's still relatively new, but because we have this thing called vendor information options now. So essentially, with V4, we for years now have overloaded grossly a lot of the V4 options to kind of represent different things to different people, to different implementers, right? Option 60 for cable modems has a whole bunch of stuff on the back end that means something to a cable provider. Doesn't mean anything to an enterprise person. So DHCPv6 3315 makes available this ability to kind of get yourself a vendor ID, and you now are authoritative for your own DHCP options. Right, so using cable labs as an example for the cable industry, we have 4491 as our vendor ID, and we have specified through our specifications work a substantial number of DHCPv6 options under our own ID and cable that we need to kind of make things happen from a V6 point of view, particularly for DHCPv6 point of view, and support the deployment, right? So I need to send a boot file to a cable modem. Well, I have a boot file option with its own code under 4491. It's unique to me, right? If you're a DSL guy, you're highly unlikely that you're going to use the boot file option if you use a boot file under my vendor code 4491. You're going to go roll your own, right? Maybe the broadband forum has their own vendor ID. This is very important because the other thing to note about this thing here is there's a lot of back and forth about this, right? Some people say, well, no, there's an absence of kind of control here. There's an absence of the opportunity to kind of oversee and shape how options are defined, right? But other people at the same time say, well, I really like the flexibility, right? I don't want to wait 3 years for the IETF to kind of specify an option, right? It all depends on what side of the fence you're sitting on, right? So, important point to note. Now, something that's not in here that's worth mentioning, is kind of related to this, is there are vendor message types that where there has been work related to vendor messages proposed into the DEC working group at IETF, right? Similar idea, but now just message types, not just options. So V4, V6 coexistence. For the gentleman that left, this is largely what we fast forwarded to. You know, whether you want to put same server, different server, same process, different process. You know, how do you want to deploy DHCPv6 if you're going to use it? And it really is on a case-by-case basis, right? You know, everybody has different constraints. You know, putting DHCPv6 on a separate server requires you to go out and actually buy other servers, right? So, you know, in tough times, maybe budgetarily, you know, budget-wise, that's not an option, right? You know, it's a case-by-case. All right, let's see here. All right, so we went through a lot of these things here, and I'm not going to kind of waste too much time on that. So let's get into some of the redundancy business here. So like I'd mentioned multiple times, there is no protocol for DHCPv6 redundancy. It's kind of, you know, there's no protocol. It doesn't exist. But in any environment, we need redundancy in some way, shape, or form, right? So some of the work that we had done, and you know, someday, soon, hopefully, we'll be able to post at least an informational document in IETF that actually outlines this with a little bit more detail. We had to do some work to make it so that we could leverage servers that support the protocol as it is today, yet get closer to being redundant, right? I'll be the first to tell you it's not perfect. It's not foolproof. It's, you know, it's because there's no kind of inter-server communication that really is going to allow for the exchange of state, right? Combination of using range subsets, server preference, and multiple servers, right? So all along the way, I've been talking to you guys about, okay, well, you have two DHCP servers. Maybe one has a higher preference, the other one doesn't, right? Well, so let's kind of dig into that a little bit deeper. If they're configured with the same /64 as the range, essentially, depending on how the server determines the 64 bits for the interface ID, I'll never, you know, statistically, I may never have a duplication. And even if I did, the client's going to detect those, decline the advertisement, and try again, right? But you have to appreciate the largeness of a 64-bit prefix and how many and what your opportunity is for that duplication, right? So in the very beginning, we talked about, well, just have overlapping prefixes. You're essentially talking about overlapping prefixes on one or more DHCP servers, leveraging preference to control which DHCP server is most authoritative for those bindings, right? Certainly would work. I can tell you that testing these things in the lab, it works. Well, you can go a step further and say, well, I really want my DHCP servers to have some form of uniqueness when they allocate addresses. So you could take a 64, assign it to DHCP servers, but now peel back and create a unique range on each DHCP servers, right? So now you essentially have this notion of split scopes. So anybody who's been around DHCPv4 long enough, before DHCPv4 failover drift, kind of got to version 13 and never went anywhere. The use of split scopes was, people used them all the time. The problem is that you waste a vast, in V4 you waste address space you really don't have. On V6, you've got plenty to waste. And I'm not encouraging you to waste it, but you have the opportunity to basically say, I want to put a /65 on one server, the other side of that 65 on the other server, different preferences, right? And now all the addresses that get allocated at that server are unique, right? So now for operational purposes of troubleshooting or to support deployment, now you can differentiate. Oh, look, that address came from server A. That address came from server B, right? And it's fairly obvious, right? Just two high-level models, right? And like I said, you could take this as far as saying, I want to have n number of DHCP servers participating in this, redundant kind of model. It just doesn't have to be two, right? I mean, if you take the first scenario where you have a /64 and you put it on 5 servers, each with a different preference, you now have essentially a farm of 5 DHCP servers that are all actively participating in the act of allocating addresses to DHCP clients. Any questions about redundancy here for DHCPv6? Now, the other thing I will note before we go too far off this, it doesn't solve the problem of availability of data not related to DHCP clients, right? So now, just bear with me, we have 2 DHCP servers. One of them is getting all the action. He dies. And I have a system that's trying to talk to him to get information, okay? But he's down. I'm not getting any information, right? So I need to talk to him to allow clients to register and kind of to do the NAC thing on the network. It's the best example I can offer. That's pretty generic. I have a problem now, right? That server's crashed. Now what am I going to do, right? So if you go back to the scenario where I was telling you earlier, we could adjust the various timers and lifetimes. You had to say to yourself, how do I get data to the other active server? How do I get it current now, right? So what you'll find is if you make the valid and preferred lifetime very almost equal to one another, and make the T2 timer very near in value to the preferred lifetime, you'll find that once the client tries to renew and can't against the original server, but wait, timeout, and then shoot over to the second server, right? So that gets you back to a place where now you have shortened amount of time of the absence of data, right? So these are the type of things that we've kind of had to explore and kind of dig into to make it so that we reduce the exposure. I guess that's the best way to put it. The exposure for the absence or the not availability of data, right? So, just a consideration from a redundancy point of view. And this slide here actually talks about exactly that. We talk about the adjustment of the different timers and the lifetimes. We talk about what I was calling split scopes or split ranges or overlapping ranges, right? All that's kind of what's up here now. So what these are at this point is configuration examples for redundancy for each of the models that we talked about. These are ISC DHCP configuration files. I basically took and made it 0db8 address space instead of my own. So you'll have to, if you choose to use these, you'll have to make some adjustments to kind of jive with what's on your network. But these will work. These were taken directly from servers in a lab where they were functioning. And there's a couple examples for DHCP, at least 2 examples for the 2 different approaches. If you want to play, I would encourage you to go ahead and do so and try some different gyrations. You'll notice here, we're setting different preferences here. And this happens to be one where we have overlapping 64s. This one back here, we have 65s. So you'll actually get allocated unique addresses. Again, different preferences. And just some generic options up top here. So some acknowledgments here. And like I said, there's, I've worked with Dibbler. I've had the pleasure to work with the ISC. Done some work with Tahi and the UNH IOL. And like I said, I'm familiar with the Cisco CNR DHCP server and as well as some others. So here we go with some DHCP server configurations. These are pretty generic, not redundancy. How you start it. Client configuration file as well as kind of commands to start it, and the relay agent. Took me a while to figure this one out, the relay agent. If you look on the mailing list for the ICDP server, I actually have a question out there. Pretty funny. All right, so real quick, anybody have a time check? Okay. Okay, so what time does this go to? 6? Okay, yeah, 6. All right, so some terminology. We're gonna make quick. We're gonna go through some of the generic slides first, because if you guys want to have some kind of interactive discussion about DOCSIS DB6, we can get right to that. So just some terminology, just so we're on the same page. Cable modem. You know what a cable modem is. CMTS. That's what cable modems terminate to. Usually there are n number of modems terminate against a CMTS. An MTA, not a mail transfer agent in our environment. While we have MTAs for mail, this is actually the device that we use for voice over IP. Set-top box, embedded MTA, embedded set-top box. DOCSIS is the data over cable system interface specification that basically defines how we do IP over DOCSIS or RF. Packet cable, the actual technology that is used for voice in most cable deployments. Provisioning, not only the act of doing DHCP, but also in the cable context, getting a boot file and a handful of other attributes that are required to bring a cable modem online. And of course, DHCP, we've kind of talked about that ad nauseum today. TFTP, Serial File Transfer Protocol, used heavily in DOCSIS, and time of day, also used heavily in DOCSIS. Some pointers to specifications that should be publicly available if you wish to read them and you are an insomniac. And an overview of DOCSIS, right? So let's kind of dig into this real quick. So we have the ability to support IPv6 in DOCSIS 3.0, right? Which is a fairly new version of our DOCSIS specifications. But we also have the ability to support IPv6 in some legacy devices that are what we call 2.0 base, right? So some of the pointers I gave you to documents will tell you, will give you information about how this is, how it was specified to put v6 into DOCSIS, right? In short, to provision a cable modem online, require DHCP, TFTP, TOD, and really that's about it, right? So there's some syslog options and some SNAP functionality, but doesn't necessarily require, they're not necessarily required to actually bring the device online. Stateful DHCP is generally required by DOCSIS devices that support IPv6, and there are some reasons for that that I probably don't want to get into right now. It's just not probably a wise use of our time, or what little we have left. Okay, so similar to V4 and DOCSIS devices, we use DHCP in almost an exact same way that V6 is, as we do in V4, right? We have the cable modem, the DHCP client, the CMTS, a relay agent, and we point it to one or more helper addresses for the DHCP server, okay? And like I mentioned earlier, a lot of our options for V6 are specified under our own vendor or enterprise identification number. Our happens to be 4491. These here are kind of, a list of the different options that we specified in DOCSIS to support, to enable IPv6 on cable modems, right? Option request option, there's actually one specific to DOCSIS, right? In addition to the one at the core of DHCP. We have TFTP, TOD, syslog, IPv6 servers, right? So these are not, you go and look in DHCP, the DC working group, you're not going to see these. You have to go look in the DOCSIS specs for these, okay? Our boot file or configuration file, again, specified as part of DOCSIS. Client configuration options. The device identifier. Now, interestingly enough, something to point out here. I mentioned earlier DOID. With DHCPv6, we use DOID, MAC address no longer, right? Well, turns out in certain environments that MAC address is actually pretty important. So we care about it. So this device identifier is actually the 48-bit MAC address of the cable modem that gets transmitted as part of the DHCPv6 exchange under our own enterprise ID. We have modem capabilities, and these are basically kind of a bag of bits that tells, it's an encoded list of option or bits that basically, once decoded, will tell us what the modem is capable of doing, right? Can it do flips, whatever? You know, it's just features, so to speak. Kind of to be blunt about it. And in the CMTS now, we also transmit information about the CMTS itself. We transmit information about the DOCSIS version that CMTS can support, as well as the cable modem MAC address, right, which is often referred to in V4 land as the remote ID. So we need, you know, that's actually an important tidbit for people who run cable networks. Same picture. The only difference here is client is the modem, relay agent is CMTS. So these are the sniffer traces from the DHCP exchange between a cable modem through a CMTS to a DHCP server. You'll notice the DOID that we use. Listen, this modem supports reconfigure. Okay, you didn't see that in kind of the regular client illustrations. This actually is worth going through. Vendor class. Now, here's another thing that's worth noting here as well. All the traces that you saw before, it was in human readable format, right? Oh, look, option 23, DNS server, IP list. You're going to find that for DOCSIS, if anybody here cares about DOCSIS, you're going to get a lot of these in Wireshark because the decoders in Wireshark haven't been built yet to decode all the different options for DOCSIS, IPv6, and DHCP, right? So in here, you would see something that said DOCSIS 2.0, DOCSIS 3.0, right? That's our vendor class. And note, our enterprise ID is in front of that. Okay. Rapid commit. It's there. It'll do it, but we don't go there. Relay agent IP. What else we got here? So this is a better illustration of how Wireshark can decode these DHCPv6 packets properly for DOCSIS. It means nothing unless you have the packet. And I left that there on purpose, not to be obnoxious either. So the rest of these things here, we have some additional vendor information off to the right there. And for what it's worth, these options here, under the vendor information option 17, we have our own enterprise ID. Under here is where we have the DOCSIS ORO and other attributes that are transmitted as part of DOCSIS. Let's see. Hold on. Okay. So the advertise I'll get into, and then I want to skip to reconfigure, and then I think we'll end on that. So if you look in the advertise part of this transaction for our cable modem, this one doesn't have anything interesting. This one will, but we can't print it. So over here is where we would send back. In this bag of bits over here, we have things like our boot file, the TFTP server IPv6 address, the TOD IPv6 address. At the beginning, nothing. At least not to us in this room at this point. Reconfigure accept, right? So the intention here is to illustrate how we've leveraged vendor information options that we specify as part of DOCSIS to bring these devices, to allow for these devices to be provisioned using DHCPv6 and support IPv6. And what I'll do is I'll jump to the tail end here and talk about reconfigure. So in reconfigure, what you'll notice here is DHCP server is instructed somehow, whether it's, it goes from vendor to vendor, to basically issue a reconfigure message to the client. Okay? Gets to the client, and essentially all that message does is says to the client, if you accept this message and it's properly encrypted and also the business, renew or rebind. That's it, right? So the client still has to go through the renewal process to actually for that reconfigure to take effect, right? So that's where you basically say, I've made a change on the DHCP server for this client or for these clients down here. Issue the reconfigure to have the change take effect using the renew, right? These traces here are exactly that message flow in a real DOCSIS environment. So you follow these guys through, and you're going to find that you'll see the reconfigure message go out, and the request and the reply come in. Okay, so questions, comments? Who wants to go to the bar? Okay. So, go ahead. I'm sorry.
Did you use IC relay or also ones in Cisco routers?
For the DOCSIS stuff?
No, I'm not sure.
So all the kind of enterprise VLAN, and the Ethernet side of things, the enterprise illustrations on the front end of this was all IC software. The tail end of this was not, right? The relay agent, so everything not DOCSIS here was ISC, right? It was the relay agent, their client, and their server. All the DOCSIS stuff was not. Actually, there was no ISC there because ISC's relay agent doesn't run inside of CMTS. That's it. I'm kidding.
Yeah, with Cisco's, right? You don't do any relaying or testing of relaying through your Cisco boxes yet.
Which Cisco boxes? So in this case, this was a Cisco CMTS.
Oh yeah, I'm sure. Yeah.
Right. So hold on, wait a minute. Hold on. Let me go back to a nice, colorful, friendly picture. No. This guy right here. Okay. So all these examples to the end. This is a cable modem from I forget who, but it's not ISP's client. It's some other DHCP client in a cable modem. This was a Cisco CMTS, and this was probably Cisco CNR DHCP. Right. Yep. And that's it. So if you guys any questions, comments, you want the sniffer traces, the binary versions, I'm happy to send them over to you. Just let me know. You guys want to talk about anything? I'll probably hang out here for a little bit. Otherwise, thank you. Paul, wait. Hold on. I'm sorry, Paul. Go ahead.
I'm just curious. If I don't happen to have a 14 million customer network, what's the incentive to V6 here? DHCPv6. We understand you guys have a unique incentive.
Well, you'd ask me about the incentive to do DHCP or the incentive to do V6.
I'm just hoping it adds some fire there. Add some gasoline to the fire, which a lot of people seem to think is sort of wet wood.
Yeah. I mean, we've been talking about that, right? I mean, that's kind of the kind of situation that we're in. I mean, I'll put it to you this way, and I don't mean to kind of get into a religious debate here. So But my feeling is this, right? I mean, if you listen to Dave Meyer, some of the guys who were talking at the main hall a couple days ago or yesterday, if you think about some of the alternatives to where we're going, right? Carrier-free nets, and or even whether irrespective of how you get to them, right? It doesn't take a lot of thought to figure out. Well, the implications there are pretty substantial, right? So my feeling, the kind of not answer to that question would be I don't think there really is if I go to V6, I get, something cool at the end, right? I think the answer to something like that is if I go to V6, I get to keep the internet the way I know and love it today, right? I get to get to a place in the future where, the things that I do happily today on the internet stay that way on the internet tomorrow, right? Unless we start down this path, start or continue down this path, sooner rather than later. It scares me on a personal note. Any hat off on a personal note. As somebody who cares deeply about the internet, it kind of scares me what to think could happen in the not too distant future. So I look at the downside of things that could potentially come as more of a motivator kind of get on the ball with DHCPv6, not DHCPv6, versus I have the opportunity to go make some food and be fantastically wealthy as a result of it. I mean,
Sure. I was just kind of wondering whether or not there's, people, I guess you haven't really operationally seen this going on yet, so you can't really say, hey, having a big address space, it's better to be able to have these separate address ranges than to do, failover in DHCP, say.
well, actually, no. I can actually talk to a couple things like that, right? So we talked about extending the lifetimes for leases, right? I can tell you that there's potential to kind of improve how networks are operated on a day-to-day basis, right? Another example of that is right now with V4, there's always churn on the network, right? I got this charge 23, I got to roll it up, change the mask, put a new address space up here, do some stuff on the DHCP server. This is happening all the time, every day, right? Well, now I put a 64 out there. I'm never going to have to do that, right? I mean, that helps simplify the way that you operate and run a network, right? Two very simple examples, right? But I'm telling you, I mean, like in the V4 world, that stuff happens every day, right? And it doesn't have to tomorrow, necessarily. But unless you have 14 million kid modems, you don't care, right? I mean, I care, People who work in that have big DOCSIS networks, they care. Anyone? Do I? Is that kind of answer?
Just care first. Is kind of the position we're taking.
Oh, that's a great.
Eventually, you're just running into the wall ahead of everybody else. It's not going to be that long before everybody that wants to grow their network gets to decide whether they're going to do increasingly arcane things with NAT before.
That is a
or they're going to just move on and do maybe slightly less arcane things, as they said.
That is a fantastic point and completely accurate. That's correct.
Well, you probably have run into a gentleman by the name of Latif.
Of course.
And so, he talks about the fantastic security and advanced security that keep the address space so big on you can possibly block it, or at least you can't block it very often.
Wow, but that's not true either. I mean, I could go download the OUI database and I could potentially mathematically calculate every address on the planet, because I only have what do you call it, 24 bits to smash around there, right? And then I can basically predetermine every 64-bit interface I take. I could do that.
I didn't say it was right. I was just wondering if any arguments
No.
also apply.
No, I'm sorry to say. I know Latif and I respect him deeply. I just, I don't subscribe to V6 is just kind of amazingly more secure. I'll be the first to tell you that to Suzanne's point, our primary interest is the largeness of IPv6. From Verizon commercial.
Maybe it's something I should ask ICD. What textile of the ICD server look like? The configuration file, you try to put 50 million modems in there.
Oh, I didn't go there.
No. We'll leave it this.
I'll leave.
Yeah.
That's not for me. Yeah, I mean, I sadly I can't. The sexiest thing I get to offer to you is, in the not too distant future, we hope to go beyond enabling DOCSIS modems, right? Because the reality situation is the interest here is very specific at this point, right? To Stan's point again, Comcast cares deeply today, right? Now maybe some other big MSOs are going to care the day after tomorrow, right? But we don't want to just do this and leave it at DOCSIS modems, right? I mean, I'd like to be able to come back and talk to you folks, in June or the fall and say, hey, guess what? If you're a Comcast country, let me know, and you might be able to surf the internet over IPv6. That would be cool. Okay. If you guys have nothing else, thank you very much for staying here and not falling asleep on me.
Thanks, John.
Thank you.